Good day everyone. This is another getting started video that forms part of the Computer Programming 143 course. This one is for Practical 6, where you guys will learn about pointers, two-dimensional arrays, and also how you're going to handle multiple files. So the practical consists of two parts. Firstly, you're going to do some assignment 6A. You're going to do some work with pointers. I'm not going to go through this in my getting started video because the instructions are quite self-explanatory and you guys would be able to follow it and implement it quite quickly. The thing that I want to help you get going with is question B. That is, you're going to use different files in order to create a working program, and what your program is going to do is it's going to plot it's going to firstly ask a user what the initial velocity and angle is at which a projectile is thrown or launched, and then your program is going to plot that trajectory. So it's a pretty cool assignment because you are now going to use some of your applied mathematics equations that you can read in the practical discussion or the practical assignment that's explained quite nicely over here. And also, you can see the output. This is the type of output that we expect. Okay, so if this crosses these x crosses, I think in some of the examples you can, for example, use asterisks as well. This is your projectile, and then you have a frame around it. Okay, so essentially, most critical thing to do to get going with this assignment is to read all the instructions very carefully. It makes reference to using a main.c file, and then to include all your projectile calculations and the frame in which it is displayed in another file called assignment6b.c and also assignment6b.h, which is its accompanying header file. So together assignment6b.c and assignment6b.h makes up the library. Okay, so the functions that you're going to have to implement in assignment 6b is the calculating the trajectory, which can be done by using if I skip ahead, by using the formulas that we provide you with, but you should also be quite familiar with them from applied mathematics. Then you have to in assignment in the projectile function or C file, clear display data. Essentially what this does is it should just draw the border of the where the projectile is in, and that essentially, so you can think now, it would be useful if you set your screen's width and height, so according to the number of characters that you will be supporting. Okay. Then you would also want something called print update display data. So if you have, for example, a two-dimensional array, which we also propose for you, then you want to add the calculated trajectory, that is the movement of the projectile, you want to add to this two-dimensional array. And then obviously you need a function that prints the data. So in your main.c file, which is your driver, you're going to have to clear the display data, print the display data. So that essentially just prints, if I skip ahead quickly, that just prints this box without the projectile movement over here. Your program should ask the user to enter an initial speed and also a launch angle. Okay, so that's in meter per second. The launch angle can be, for example, in degrees. And then you calculate the trajectory. Okay, so there you're going to have to support a certain number of trajectory points. So, for example, you support 300 points, and each point has an x and a y component. Okay, so there is another point where you're going to have to use a two-dimensional array. Then you can update your display data, so add those x and y components or coordinates to the display data two-dimensional array and print it. And then loop, ask the user if he wants to do it again, and essentially repeat all these steps then. Alright, so I think okay guys, so this is my implementation of the program. I'm going to show you some of the files. Obviously, not everything, so we want to have you do some, have you do the work as well. And I haven't named my separate projectile library Simon6b.h and .c. I've called it projectile.h. Okay, so from my projectile header library, I'm going to be able to get the I'm defining some constants, my display size with my width, my height, the maximum number of points that I'm going to have. Gravity is obviously a constant that you should be defining, and these are additional constants that you can use to speed up your calculations by noting that essentially you're going to have some symmetry in the calculations side. But the most important thing are these function prototypes over here. So essentially we have these 4 functions called Calc Trajectory, which takes in the speed the user gives, it's a double, takes in the launch angle, and then by using call by reference, it returns the trajectory data as a 2-dimensional array, remember that. Then the other thing that you need is you need a function called clear display data over here. Essentially what it's going to do is it takes in the display data array. It's also that's also a 2-dimensional array, and it just clears it so that only the frame is drawn. Okay. Update display data takes in the canvas or the frame, takes in the trajectory data, and then embeds the trajectory data onto the display data. Print data just outputs the entire thing. Okay, so that's what your header file should look like. Now I'm not going to go into, obviously we expect you guys to implement this projectile.c functionality. What I'm going to help you a little bit with is the main.c driver so that you can get going quickly. Okay, so firstly your display data, that is, as I said, like if I look now at my canvas over here, my box, the display data is this frame around the projectile movement, and you control the width and the height in your H file. So in my example, I've said that my width is 80 characters, my height is 40 characters, but you can adjust that obviously according to your requirements. So so the display data is a 2-dimensional array that contains that. Then we have our trajectory data. Remember, it's the number of points that your projectile will be sampled at in a way, right? By 2, the second dimension is 2 because we've got an x and also a y component. Then this trajectory data, obviously because it entails some mathematical calculations, is a, just want to put this off, notifications, sorry about that. Okay, the trajectory data is obviously a double precision array. Then we just declare some array A that's used to input variables from the user, and then these are the variables that we're going to get: the initial speed the user specifies and also the launch angle. Set buff, just our standard way which to sort out the Eclipse printfs. Now we're going to loop. How are we going to implement that loop? We want to loop until some condition becomes true. That's essentially, if you can remember back, a sentinel condition, right? So we're going to use a do while for that purposes. What we're going to do is we're going to prompt the user to enter the initial speed and angle. We're going to read that, and then we're going to start calling our projectile functions over here. But before we go into more detail there, what happens after we've calculated and displayed the projectile? Well, we prompt the user, or we ask the user, does he want to continue or not? So if he presses 0, scan if that into this temporary variable A, and we check. If A is not 0, we continue again. If A is 0, then we end the program. Okay, so over here in the middle part, that's where the magic happens. So that's where we are going to read the projectile function. So clear display data essentially clears our display data, print prints our display data. So if I call it directly after I cleared it, then I'm only going to see my blank canvas. Calculate trajectory calculates the trajectory by reading the initial speed and the launch angle, and then updating this trajectory data 2-dimensional array, which I do over here. Okay, so I know it's a mouthful, but I think that's more or less the layout that you guys can can use. You obviously have to complete now the inner workings of this, my equivalent of your assignment 6B library, which is the projectile movement. Okay, guys, good luck. I'm sure it's going to go well.